Okay, class, welcome back. Today we're going to continue with more math in chemistry and moles by being able to determine the mass in moles of compounds. My objective for you today is that you would be able to solve for the molar mass of a compound and use it to either solve for moles or an unknown mass of a compound. In saying that, let's dive into our lecture. So, in our last video, we discussed how to find the molar mass of a specific element. The issue becomes, in chemistry, we deal with much more complex substances than just pure elements. A majority of the time, we are going to be dealing with substances that contain multiple elements. For example, if we have water, we have H2O. We know that we have 2 hydrogen atoms to 1 oxygen atom. How, though, do we find the molar mass of this compound? The answer is we just add up all the components of the chemical formula. In order to do this, I typically set up the following table. My headings are element, molar mass times quantity, and that equals total. So for each individual element within the equation, I fill in this portion of the graph. So for my formula H2O, my elements would be hydrogen, or H, and oxygen, or O. I would then put each of these elements in their different lines. Next, I would write their molar masses I found on the periodic table for each of these elements, so 1.0 for hydrogen and 16.0 for oxygen. Then I would carry down my multiplication sign for both rows. Now I would look at my subscripts behind each element to tell me the quantity of each of them. If there is no subscript behind them, then it is understood that there is only one of that element. So there are 2 hydrogen atoms and 1 oxygen atom. Next, I would multiply my molar masses times the quantity to get my totals. So 2 times 1 is 2, and 16 times 1 is 16. My last step is to find my molar mass of the compound by adding up my molar mass totals. So 16 plus 2 gives me my total molar mass for water of 18 grams per mole. Now with this knowledge, we can solve mass to mole problems for compounds the same way as we did for our individual elements, just making sure we have the appropriate molar masses for our compounds. So say I wanted to see how many moles are within 85 grams of zinc chloride, or ZnCl2. My first step of this problem is to solve for the molar mass of my compound. To do this, I set up our molar mass table as so. Now let's fill out our elements, so zinc, Zn, and chlorine, Cl. Then we add our molar masses, so 65 for zinc and 35 for chlorine. Now we multiply these quantities by their quantity, so 1 for zinc, because there's no subscript behind it, and 2 for chlorine because there's a 2 behind our Cl. This gives me my totals of 65 for zinc and 70 for chlorine. Now we just add these together and we get 135 grams of zinc chloride per 1 mole of zinc chloride. Now that we have our molar mass of our compounds, we can set up our equations. We take what we know and put it over 1. So we are given 85 grams of zinc chloride. This means we take our 85 grams of zinc chloride and put it over 1. Now in order to convert to moles, we are going to have to use the relationship of 1 mole of zinc chloride over 135 grams of zinc chloride. This gives me that there are 0.63 moles of zinc chloride present within these 85 grams of zinc chloride. Okay, let's say we wanted to go from moles to a given mass of a compound. Let's see how this works. How many grams of iron 2 nitride are in 2.64 moles of iron 2 nitride? Well, the first thing we are going to need to know is the chemical formula for iron 2 nitride. That is Fe3N2. Before we start trying to convert our moles, we need to find our molar mass of our compound. So let's set up our molar mass table. Our elements are Fe and N. Their respective molar masses are 56 for iron and 14 for nitrogen. We have 3 iron atoms in this compound and 2 nitrogen atoms in this compound. So they're going to be under the quantities. This will give us 168 grams for our iron and 28 grams for our nitrogen. Our total molar mass is 196 grams of iron 2 nitride per 1 mole of iron 2 nitride. Now we go back to our problem. We put what's given over 1, so 2.64 moles of iron 2 nitride over 1. Then we multiply it by the relationship of 196 grams of iron 2 nitride over 1 mole of iron 2 nitride. Once I do the math, we get that there is 517.44 grams of iron 2 nitride and 2.64 moles of iron 2 nitride. Before I finish up this video, let's connect everything we've talked about in the last 3 lecture videos so far. Let's say I'm asked to calculate how many molecules of water are within 150 grams of water. How do I do that? Well, this is nothing more than having to convert our grams of a compound to our moles of a compound, then taking our moles of a compound and converting it to atoms using Avogadro's number. So, we found that the molar mass of water earlier is 18 grams per mole. Like in all my mole problems, we're going to put what we know over 1, so 150 grams of water over 1. To get to moles, we would multiply it by 1 mole of water over 18 grams of water, or its molar mass. This gives me that there are 8.3 moles of water. Now I'm going to take this number as my new known and put it over 1. I would then multiply it by 6.022 times 10 to the 23rd molecules of water, or Avogadro's number, over 1 mole of water. This gives me 4.998 times 10 to the 24th molecules of water in our original 150 grams. Okay, that's enough for today. Today you learned how to find out the molar mass of a compound, use that molar mass to find moles of a compound, and to convert from grams of a compound to represent particles of that compound. I hope this video helped you out, and keep up the good work in the classroom. See you later.